Ya, Assalamualaikum warahmatullahi wabarakatuh. In this session, I will present my topic with the title of Fractal Motifs Generation using variations of parameters in Fourier set function. Please let me introduce myself. My name is Rizal Isnanto. Together with our college, there are Ahmad Hidayatno and Ayub Ajulian Zahra Makrina. We are from Department of Computer Engineering. Me, myself, and two other of my colleagues is from Department of Electrical Engineering from Faculty of Engineering, Diponegoro University. Outline of our presentation is the first is introduction, the second is research method, the third is system design, and then result and discussion, and the final is conclusions and suggestions. For the introduction, okay, Batik is the art of crafting cloth that has high artistic value and has been a part of Indonesian, especially culture, for a long time. While the fractal concept is the generation of images graphically with self-similarity properties produced by recursive or iterative algorithm to produce a new image form. And then Batik and fractals are two different concepts. Batik is in the area of art, while fractals are mathematical concepts related to iteration and self-similarity processes. However, Batik and fractals lead to a new concept of Batik, namely fractal Batik. In fractal Batik, fractals are used to design and redesign new patterns using computer software. Okay. For the research method, the research material is taken from Nusantara or Indonesian archipelago Batik motifs, more specifically the motifs of Surakarta, Yogyakarta, Pekalongan, and Cirebon, which will be used as learning materials for developing contemporary Batik motifs using fractals. Okay, there are 18 traditional Batik motifs from the 4 regions above that will be taken as a reference. There is Batik motifs of Parang, Kawung, Sawat, Sidamukti, Truntung, Satrio Manah, Semen Rante, Jelamprang, Pekalongan, Liong, Parangkusumo, Tambal, Pamiluto, Sidoasih, Wahyu Tumurun, Semen, Ceplok, Megamendung, and Nitik. The names of the Batik motifs are taken from reference number 1. Okay, and then this is the instrument used in this research consists of hardware and software. Can be read in this slide. Okay, for fractal concept, this is unconventional mathematician Benoit Mandelbrot created the term fractal from the Latin word fractus, which means irregular and fragmented, in 1975. This is the examples of fractal graphics from Sierpinski cascade and the Koch snowflake. Okay, for fractal characteristics, there are 4 characteristics. The first is self-similarity, the second is scaling, the third is bounded infinity, and the fourth is fractal dimensions. This is the equation for fractal dimension. This is the example of fractal graphics from Mandelbrot and Fourier set. Mandelbrot in the left side and the Fourier sets in the right side. This is some samples of Batik motifs from Nusantara or Indonesian archipelago. Okay, for the research method, this is the algorithm to generate the Julia set. This is the pseudocode for generating the Julia set. Okay, in the design, the aspect considered include the possibility of future development, program application, program effectiveness and efficiency, program capability and user friendliness that is realized in a graphical user interface or GUI display. In this system, the process of generating fractal Batik images consists of 3 steps, namely, the first determine the shape of the function in the set of Julia set for several Batik motifs to be chosen. Okay, this is the equation. The second, computer programming with Python software. And the third is design the fractal motif of Batik using the Julia set. Okay, this is a program code uses the Python language. The following is a pseudocode that is used as the basis for writing an application program. This this is the example of a GUI design. This is the home page. This is Julia set generator. This is the input we should type in this for iteration. And this is the sliding push button. This is if we shift right, this is increase the number of iteration. If we slide to the right, this is decrease the number of iteration. And then this is C. C is a complex number, consists of real number and imaginary part. This is also use the sliding push button is for real of a complex number and imaginary complex number. If we shift to the right, this is increase the number, and if we shift to the left, this is decrease the number of real or imaginary part. This is the graphical fractal using Julia set. This is considered to the C. If we type this the image, the graphic will be generated in here. Okay, for the implementation, experiments were conducted with many variations in the parameters of graphic images. Variations of these parameters can be seen in table 1. This is the variation of graphical testing parameters. The type of the image, we used HSV colors, hue, saturation, and value colors. And this is the column for number of colors levels. We use 15, 30, and until 60 and 80. And this is the value of C. C1, C2, C3, C4, C5, and C6 with the parameter of real and imaginary part in this. Okay, for the table 2, this standard parameters for image plotting. This we use image size and range of image window. Image size with size of 400 and height size in 480. This is the range of image window. This will start -1, real end in 1. Imaginary part start with -1.2 and imaginary end ended in 1.2. This is the result of the images generated by Julia Fractal. This is the comparison of fractal image with existing Batik motifs. This is in the left side is fractal images generated by Julia set, and on the right side is the existing Batik motif This is the comparison between two image from Hulia set and from existing batik motif. This is for the batik Liong motifs. This is considered to be I think similar to batik Liong motif. The second is for the complex number C5 with iteration 18. Okay. This is for iteration 16. For iteration 113. And then complex number C2 for iteration 150. Considering similar to batik Parangkusumo from Yogyakarta. This batik Megamendung from Cirebon is considering to be similar with the fractal images with complex number C1 with iteration 30. Okay, for discussion and conclusion. From experiment conducted with different variation when generating fractal images, some point can be analyzed as follows. For the greater number of iterations, the resulting image will be more detailed and the number of colors will increase. In other words, for a smaller number of iterations, a simpler image will be produced with fewer colors. This applies to the resulting image with the Hulia set function. For fractal function using the Hulia set, the result image is influenced by the value of the complex C and the number of color or the number of gray level indicated by the number of iterations. Or we can say that the greater the number of iterations, the more color or gray level raised. Okay, several variations of input parameter produce images that are close to traditional batik motifs. In this research, traditional motif that can be approached by a fractal function are batik Liong, Nete, Ceplok, okay, Parangkusumo, and Megamendung motifs. For other traditional batik motifs, experiments are needed by changing existing parameters. Okay, in general, changes in the number of iterations and the value of color or gray level, it is explore the variations of the set, the Hulia set. Okay, number 5, the similarity between Hulia set patterns obtained from parameter variations with certain batik motifs is based on subjective observation from readers or user of this application. There is no objective measure that states that the Hulia set pattern obtained is similar to one particular batik motif. Therefore, one's perception of the similarity between Hulia set pattern and batik motif may be assumed that the resulting Hulia set pattern show no similarity at all with batik motif. Some examples of Hulia sets display show patterns that are very far from batik motifs that are used as reference. This is caused by the number of variations of complex numbers, as one of the parameters of Hulia set generation is infinite. So that it has a great opportunity to be different from the observed batik motif. However, Hulia set motif may produce subjective motifs that are beautiful, so that can be used as contemporary as well as innovative batik motifs. This is a suggestion based on conclusion of the research that has been taken. Some suggestions are proposed as follows. Number 1, to get the appropriate batik motifs, it is necessary to test the parameter of the generation of Mandelbrot set and Hulia set fractal images to get a variety of images that are suitable to be used as batik motifs. And the second, for the next research, a set of special application software can be developed for generation of fractal imagery that is implemented in many fields, especially in computer-based graphic art, not only in the design or batik motifs. Thank you. This is the end of my presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.